This is a review video for a chapter in Algebra 1 that is about inequalities. So the book that I am working from, this is chapter 6, but it could be located somewhere else. It's all about linear inequalities. It starts off very basic here. If we look at number 1 and number 2, all we're asked to do is to draw a graph of the inequality. So the things that are important here is that if it is equal to or not equal to. So 1 is not equal to because it doesn't have a line underneath the inequality, whereas 2 does have a line underneath the inequality, so 2 is equal to. So if it's not equal to as an inequality, when we put that on a number line, that gives us a non-filled in circle, so just like a regular circle. But if it is equal to, then we're going to draw a dot that is filled in on our number line. So b is greater than 1, we're going to put an open circle at 1. And then we're going to shade the direction of the numbers that are bigger than 1. So if you think about that, that's numbers like 2, 3, 4, 5, 6, 7. So we're going to shade to the right. Another way that you can tell which way to shade is by pretending that this is an arrow and saying which way does the arrow point. That only works if your variable is on the left side. So b is on the left, so we can use that trick. If b wasn't on the left, if it was on the right side, then we would have to move it around, and that'll happen later on in the video, so you'll see what I mean. On number 2, it's equal to, so we'll put a filled in circle at -6. We want to shade all the numbers that are less than or equal to -6, which is numbers to the left, or we can look at the inequality and say, that looks like an arrow pointing to the left. So if you notice the way I'm shading, it helps that I am using red, and I'm using, mainly the fact that I'm using red and it's coloring over where you can see it. Make sure when you shade on a number line that it's easy to tell which way you shaded, that it's easy to tell whether it's filled in or not. A trick that some people will do is they'll actually go up, and some teachers really like that. Make sure you know what your teacher wants you to do. I personally just want it to be obvious what you're doing, which way you're going and things like that. Doesn't matter to me otherwise. On 3 through 6 here, we're going to solve the inequality and graph its solution. So the part with solving means that we should get an answer that is another inequality, but the inequality should be solved for a variable, just like when we solve an equation, we solve for x or whatever our letter is. So on 3, to get r by itself, just like in an equation, we're going to subtract 9 from both sides. 8 minus 9 is -1. We're going to keep it as greater than. We want to keep track of that inequality. There's only 2 reasons to change the inequality. And if it's greater than and it doesn't have an equal to symbol, there's not anything that we could ever do that would cause this to all of a sudden switch to an equal to. So make sure you're paying attention to your inequality as you go along. But if we want to graph this, we actually want to move this, flip this around so that the variable is on the left, so we can use our trick for graphing. So if I put r on the left and I put -1 on the right, what I have to do is flip the inequality so that it's going the other way. It was greater than, so now it's going to be less than. So the numbers I want to shade are starting at -1 with an open circle, and then I want to shade to the left, because I want to shade all the numbers that are less than -1. So it may be that you can take this and shade it the correct direction by saying, if -1 is bigger than r and I want to shade r, which way does that mean? But a lot of us would rather just use that trick where we look at the inequality for the direction to shade, but you have to have the variable on the left side in order to do that. On number 4, we need to solve this for x, so we're going to divide both sides by -7. And if you are reviewing right now and not learning for the first time, you'll remember that when we divide by a negative for an inequality, it flips the symbol around. So that's the only other time that our inequality will change, either because we're changing what side our variable is on, like we did on 3, or in this case, if we multiply or divide by a negative number, it flips it so it's the other way. So it's the fact that I divided by a -7 that does that. It doesn't matter that the 70 is negative. It just so happens that it is. What matters is I divided by -7. So this is a filled in circle at 10. Our variable is on the correct side, so we're going to shade to the right. We want the numbers that are bigger than 10. On 5 and 6, there's a couple more steps to this process. Like on 5, just like in an equation where we have something right next to our variable and then something added or subtracted, we have to take care of what's out here being added or subtracted first before we do the division. So it's like opposite of the order of operations we use when there's not a variable around for an equation. So we're going to subtract 5, which gives us -3m is greater than or equal to 18. And then we'll divide by -3. And because we divided by a negative, we're going to flip the inequality around. And we get m is less than or equal to -6. So at -6, I'll put a filled in circle. Then I'm going to shade to the right. I mean the left. That's totally the direction I'm going. The left. Number 6, there's actually 2 ways that you could do this. One is we can actually divide by that -5 on both sides to start off. The other way is to distribute. I feel like more of us would probably think to distribute by -5 to start off. You should still come up with the right answer if you do it all correctly in between. Make sure when you distribute here, -5 times -1 is 5. -5 times a is -5a. Lots of people will even draw the arrows up here, and yet they will forget to actually like multiply the second thing by -5. Now, we don't have to change the inequality because we didn't do anything yet. Like, we're just simplifying what was already done. Or another way to look at it is we didn't do it to both sides, that -5. So there's no need to flip the inequality yet. But we do need to subtract this 5 from both sides and have -5a is less than 10. And then divide by -5 and have a is greater than -2. So we put an open dot at -2 and then draw to the right. So this is kind of the first couple sections that you would find in an Algebra 1 book with that in a section or a chapter about inequalities. From here, like that's really actually typically review from pre-algebra. So from here, we'll get into stuff that might be a little bit more new, like compound inequalities. So a compound inequality is an inequality that has 2 different inequalities at the same time. These inequalities are either and or. And inequalities, you shade between the 2 numbers you get, or you shade outside the 2 numbers you get. One way you can remember this is or has an O and outside has an O. When we have an and, there's 2 ways that can look. 7 and 9 are both ands. 9, that should be obvious because it says and. And it should be obvious that 8 and 10 are ors because they say or. So the question is, why is 7 considered an and? Besides the fact that I just told you it's an and. Well, what's happening is that x right here is in between 2 numbers. And so once we solve, it'll still be in between 2 numbers. And if x is in between these 2 numbers, then it has to be something in the middle, which is the very definition of us shading between those two numbers. So to solve this, we want to look at the middle here and say, how do I get x by itself? Well, and when I divide by -2, because there's actually 3 parts to this inequality, I'm going to divide all 3 things by -2, like so. So -18 divided by -2 is 9. I divided by -2, so this is actually going to flip both of our inequalities. -16 divided by -2 is 8. What this is telling us is that x is between 8 and 9. It's saying, if I read this, it's saying 9 is bigger than x, and x is bigger than 8. Well, if you are stuck in a before algebra kind of mindset, you might be thinking, well, there's not actually anything in between 9 and 8. But don't forget all those decimal numbers. There's infinitely many numbers in between 8 and 9, like 8.5 or 8.4362789. So we're saying the only answers that work for this are between 8 and 9. Now, this is how we came up. This is like our answer when we solved. But actually, the better way to put this, like normally when we have it written this way, we actually will put the smaller number first, or the more negative number first. To do that, we'd flip the inequalities around again if we just write it in the opposite order. So technically the second way is the better way of putting that, but depending on your teacher, they might accept it either way, like I will accept it either way in Algebra 1. On 8, it says or. So these are two completely separate inequalities here, separated by this or. So we're going to take 10x greater than 90 and solve that by dividing by 10. So we get x is greater than 9. And then we're going to look at x minus 6 is less than or equal to -8. So that's going to add 6 to both sides. So x is less than or equal to -2. So one of the things with this is, by the way, is we're solving the inequality. So this is the answer to our inequality, like that's our solution. And then we're being asked to graph that solution. So it's like our answer really has 2 parts. This inequality that I have, set of inequalities that I have circled, but also the part where I graph it. So I'm going to put an open circle at 9 because it's not equal to 9. I'm going to put a filled in circle at -2. And then as far as shading goes, since it's an or, we know that we should shade out. But also the inequalities tell us if we shade bigger than 9, that's to the right of 9. And then if we shade less than or equal to -2, that's so whether we can say, oh, it's an or, so it's out, or whether we look at the inequalities, either way we should be able to come up with which way to shade. Number 9. We just need to solve this. It says and, so we'll do that. We'll do -8 on the first one and get x is less than or equal to -3. We'll add 6 to both sides on the second one and have x is greater than -9. So x is less than or equal to -3 and x is greater than -9. So that means that we're shading between -3 and -9. -9 is an open circle, -3 is a filled in circle, shade between. Now we could write the answer on 9 combined like what it was, is to take the number on the left, put a less than symbol, x less than, and then put the number on the right. So we're saying that because when you think of this, you're actually saying x is bigger than -9 because it's like you're reading the inequality backwards. X is bigger than -9. X is smaller than -3. That's how I think of it personally. But either way, you can leave them separate, you can put them together. What we can't do is this is or as in both of these answers work. You can't combine an or. So like on this problem, I would not want to put -2 is less than or equal to x is less than 9, because this implies that I'm shading between, and I'm not. So that's wrong. Don't do that. Don't ever do that. On 10, this is an or, so we should shade out. We're going to do -7. M is less than or equal to 6, or divide by -3 on the second one. M is greater than or equal to 7. So we're saying less than or equal to 6, greater than or equal to 7. This is kind of the opposite of what happened to us on number 7, because they're really close together and then we're shading out instead of between. So again, if we're ignoring decimals, this seems like a really uninteresting sort of thing, because there aren't any numbers in between 6 and 7 except for decimals. But I mean, there's a lot of decimals in between. A whole lot. The next thing, typically in a chapter on inequalities, as strange as it may seem, is that we switch gears and we start talking about absolute value equations. And then the reason we do that in this section is because then we talk about absolute value inequalities. With both equations and inequalities, when we have absolute values, we should end up with two answers. So for inequalities, it's going to end up being a compound inequality. But for equations, what's happening is we're saying absolute values make things positive. So I don't know what 6x is right now, but I know that it could be either positive 24 or it could be negative 24. Because if it equals positive 24, then the absolute values will make it stay positive. If it equals negative 24, the absolute values would make it turn into a positive. And so both of these are an option, and we'll solve both of them and get two answers. So the thing that we have to know, whether we understand why we're doing this or not, like as far as achieving what we want to for a quiz or a test or homework or whatever, the steps for this are take what is on the right side and make it negative for another equation. So for one, we leave it alone and use positive 24. For the other one, we change it and make it negative 24. We don't ever change what's inside the absolute values when we're doing this, which seems weird because that's what we've been taught to do with absolute values, is change the inside to positive. But that's not how it works. For instance, on 12, I'm not going to change this to 6n plus 3 because what we actually want to say is that, well, 6n minus 3 could equal a positive 57 and then get changed to positive, or negative 57. And we want to figure out what two numbers work for that. So the cool thing about this is that my steps for solving end up being the same. So I'd add 3 to both sides on the first one, and I'd add 3 to both sides on the second one. You do have to be careful. Pay attention to negatives. Negative 57 plus 3 is negative 54. Divide by 6 on both sides. 10, that's our first answer. Divide by 6 on both sides and get negative 9. So even if we forget how to solve absolute value equations, we should at least hopefully be able to get one answer. But it's that second answer that really makes the difference between having a regular equation and an absolute value equation. On 13 and 14, there's an added step, because on the side with the absolute value, the left side, there is something extra that is outside of our absolute value. So another rule with this is that we can't write our two equations until the absolute value is by itself. So before I do anything else, I want to add 2 to both sides here, so that I have b over 7 equals 1. Notice I still wrote the absolute value bars. I'm not ready to get rid of them until the absolute value is by itself on the left side. Now that it is, I'm going to write b over 7 equals 1 and b over 7 equals negative 1. And I'm going to solve that. So both of these, I need to do the same thing and times by 7 on both sides. So b equals 7 and v equals negative 7. On the next one, we want to do the same thing. We want to move that 4 first before we do anything else. Have k plus 8 equals 5. Then we want to split this up into k plus 8 equals 5, k plus 8 equals negative 5. Subtract 8, k equals negative 3, and subtract 8 again, k equals negative 13. Negative 3 and negative 13. Checking my answers real quick. Yep, good to go. So that's with equations. With inequalities, there is one extra step we have to deal with. Because when we look at this and we start off, it starts off the same way. We have x minus 1 has to be greater than or equal to positive 5. Then we're going to do x minus 1, and we are going to have negative 5. Divide by a negative, it flips the inequality. The second inequality here that we write also needs to flip. Because it's kind of like the reason that negative is there is it has to do with us multiplying or dividing by a negative, if we want to think of it that way. So the important thing is to remember on the second inequality, you want to flip it, the one that you made negative. When I solve this, this is going to be an and or an or. I can actually tell based on this. Greater is always or. Less than is always and. Now that's once you've solved for the absolute value that you look. So technically on 17 and 18, I'm not ready to look until the absolute value is by itself. But here, I already know this is an or. I'm going to add 1 to both sides and have x is greater than or equal to 6. Or x is less than or equal to negative 4. Now, if I didn't remember that trick for knowing it's an or, well, I would just graph this and see what happens. Greater than or equal to 6 is a filled-in circle at 6, and then I would go to the right because it's greater than or equal to. And what should happen is we shouldn't ever shade two things the same direction. So even if you forget at first that this second one was supposed to change directions, once we go to graph it, we should say, oh, these aren't supposed to go the same way, so we'd maybe remember to flip it then. So negative 4, we're going to go and put a closed circle, a filled-in circle. It's saying to shade less than, so we're going to shade to the left. 16. So we're going to have 3x plus 7. And then 3x plus 7. Flip the inequality. And put negative 22. We're going to subtract 7 on both of these and then divide by 3. And by the way, it's really easy to get fractions on these. It's actually, like as a teacher, if you make it your goal to make these not be fractions, it's actually pretty challenging. It can be done, but actually it makes the equations kind of boring in a way. Basically, you have to keep using the same number over and over again, or multiples, whatever. So the first one divided okay. The second one, 3 does not divide into negative 29. Because we have to graph this, what we want to do is change it to a mixed number or a decimal, but decimals are not as cool as mixed numbers. And it's actually easier to get the mixed number if you know what you're doing. 3 goes into 29 9 times with 2 left over, so this is 9 2/3, negative 9 2/3. When we graph this, we know it's on 5. Negative 9 2/3 is in between negative 9 and negative 10. So you probably don't have to be super precise there, just as long as you're between those two numbers, or being pretty close to 10 is also pretty good, but it does shade between those because it's less than or equal to 5 and greater than or equal to negative 9 2/3. 17 and 18, both of these we need to solve for absolute value first. So on 17, I'm going to add 9 to both sides and have 2 minus 9p is less than 47. Then I'm going to write 2 minus 9p is less than 47. 2 minus 9p is greater than negative 47. Remember, we wait to flip the signs till after we've solved for the absolute value. This is where lots of people mess up. So subtract 2 and get 45. Divide by negative 9. We get p is, oh, we just flipped. Or we need to. I didn't yet, but we need to flip because we divided by a negative. Those rules still apply. So greater than negative 6. 5 greater than negative 5. 45 divided by 9 is 5. And then minus 2 minus 2. Negative 9p is greater than negative 49. Divide by negative 9. This is another mixed number. Flip the inequality. It is positive. 9 goes into 49. 5 really close to 5.5. This is an and, because it was a less than symbol right here. This was an and also. Remember that the inequalities are part of your answer and the graph is part of your answer. These are open circles, negative 5, 5 and 4/9, and shade between. 18, we want to add 10 to both sides. So we have 2k plus 4 is greater than or equal to 4. Then we want to split this up. 2k plus 4 is greater than or equal to 4. 2k plus 4 is less than or equal to negative 4. So we want to subtract 4 from both sides. And we get 2k is greater than or equal to 0. Divide by 2. This makes people uncomfortable for some reason. 0 divided by 2 is 0. That is totally fine. Dividing by 0 is where you should be uncomfortable. Not whenever it's on top, when it's on bottom. K is less than or equal to negative 4. So bigger than 0 or less than or equal to negative 4. So both of those are filled in circles, and we should be shading and to the left, negative 4. The last thing that's typically in a section like this, maybe not the last, but usually around the last-ish, is graphing in 2 variables, which just makes things more fun. Since we have 2 variables, we have to use an XY axis instead of just a number line. We're going to graph like we did in an earlier chapter on graphing, where we look at the y-intercepts and the slope. The other thing we add to this is instead of filled in circles and open circles, it's equal to, it's going to be a solid line like normal, but if it's not equal to, we're going to make it a dashed or dotted line. I personally prefer dashes, but you might prefer dots, and that's okay. Just so long as it's not solid, we're good. So, and then we'll talk about shading here in a sec. So we start at negative 5. We want to do a positive slope of 5 over 1. So I'm going to go up 5 and right 1, because that's both of those are positive. I can do it again if I want to. I apologize in advance for how my line might look, because drawing on a computer screen is hard. I mean, it could be worse. So here's my trick to knowing which way to shade. Is if it says greater than or equal to, Greater than or equal to means we want to shade above this line. The question is, where is above this line? Particularly because I drew a really, really bad looking line. So the trick is you put your pencil anywhere on this graph, and since it's shade above, we're going to draw an arrow straight up. Whatever side of your line you just drew that on, that's where you're going to shade. So I'm going to shade this side of my line because that's the side that that arrow I just drew is on. So all of this gets shaded. All of this. Every single bit. A dashed line, I need to make sure that I'm aware of that before I get too carried away, especially if I'm using pen, which I shouldn't because this is math. The number in front of x is 1, so my slope is 1 over 1. The y-intercept is -1, so I'm going to put a dot here, then a dot here. I can put more dots, or I can just go for my dashed line. It should look like this. And then we're going to shade, since it's greater than, we're going to shade above again. So there are some later on that are below, but since I want to shade above, this line to me, it's easier to tell which way is above, but we can still use our trick and say, well, if I go up, that's the side, so I'm going to shade all of this. Make sure that when you're shading that it's still obvious that your line is either solid or dashed. Like if you shade right up to the line really darkly, it might be hard for your teacher to tell, and that would be sad for them. 21. Hey, this one's less than or equal to. It's a solid line because it's equal to. We're going to start at 4, and our slope is negative, so we're going to go down 3 and right 1. Then to shade this below, instead of drawing an arrow up, we're going to draw an arrow down. So we're going to put our pencil somewhere on here and draw down. That's the side that is less than or equal to, so this side right here. Now, x and a y, it just has an x, so we have to remember from our earlier chapter on graphing lines that x is a vertical line because its slope, m, is undefined. So we need the kind of line where a skier would have an undefined amount of fun, which is up and down. So we're going to draw a dashed line vertically through -3. Now, I can't draw above or below this line, so I need to think about, since it's less than, where are the numbers for x that are less than -3, which are these numbers over here. These numbers are less than -3, so we're going to shade all of this. And again, like, see how if I get really close to my line, it's going to start making it hard to tell if that's dashed. Don't do that. That's not helpful. On 23 and 24 and 26 on the next slide, we need to solve for y so that we can graph. So I'm going to subtract 2x. Get y is less than -2x minus 2. And then graph like what we've been doing. So start at -2. My slope is down to right 1. If you're having a lot of problems with graphing, and I might have some videos on that. If I do, they would be chapter 3. Or you could look up, just Google graphing linear equations. It's less than, so less than for this line, draw an arrow down. That's this side right here. 24, we want to solve for y, and this is actually a really similar equation because we've got lots of 2's, but this time I have -y instead of positive y, and believe it or not, that makes kind of a big difference because I don't want to leave it -y or accidentally forget that that negative's there. I want to divide by -1, And that means that it flips the inequality and changes all of these signs. So if we don't remember to do that, we will not get the answer right. That's over 1, so up 2 over 1. This is a solid line. We want to shade less than, which is below. This side. These are the last two I have. So y, we can still think of as slope-intercept form if we put a 0x, meaning that this has a slope of 0, so it goes through 3 is a horizontal. Or we can just remember that y without x is a horizontal line. So dashed line at 3. If I want less than, and it's a horizontal line, I can use above or below. So that's below goes greater than, we shade above. On 26, we want to subtract x from both sides and get negative 2y is greater than negative x minus 10. Divide both sides by negative 2. When we do that, two things need to happen. We need to flip our inequality because we divided by negative. Then we have to do both of these. So this is like a negative 1 over a negative 2, which is a positive 1/2 x. Negative 10 over negative 2 is a positive 5. We're going to put a dot at 5, go up 1 over 2. And dash, because it's not equal to. And then it says less than, so we're below. And that's pretty typically what is covered in an Algebra 1 text when we're talking about linear inequalities. So happy studying.